So this is section 9.5, special products. Okay, so this is really similar to what we were doing before when we were doing the FOIL method in the last section. These are just kind of some special case situations that you might see that always follow a similar pattern. This will be more important when we go on to the next chapter because we're going to do factoring with these same types of things. And it'll be much easier to do your factoring if you remember how to do these than to do FOIL with those. And I'll show you that next chapter. But this is it's more beneficial for next chapter than it is for this chapter. Okay, so the first thing we've got here is square of a sum. So we remember squaring something is taking something times itself. So like if I've got a plus b, so that's where they get the sum part, is a plus b, squared, that's the same, so a plus b squared is the same as a plus b times a plus b, okay, because it's something times itself. Same thing works for square of a difference, so basically you've got a minus b in this case, squared, oops, this one the squared should be on the outside. So a minus b squared, so this would be a minus b times a minus b, okay. With these, they're always going to follow a pattern, so when you do it, it's always going to be your a squared out front, so whatever this value is squared, and then in the back, it's always going to be whatever this value is, and then your middle is always going to be basically double whatever this is times this is. So basically 2 times whatever a times b is. Okay, and you'll kind of see that when we do some of the problems here. Really similarly, we've got difference of a square. So basically, again, your first is always going to be whatever this is, whether it's a number or a letter, whatever, times itself. The last one's going to be whatever is at last times itself, and it's going to be plus there. Even though it's subtract here, it's going to end up being plus here because negative times a negative equals a positive. And then our middle is going to end up being negative there. That's the only difference between the sum and the difference. But you'll kind of see that as we do some of these problems out. Alright, so we want to find each product. So we've got b plus 5 in parentheses squared. So we know that's the same as b plus 5 times b plus 5. Okay? So what we were doing before is we were just doing FOIL, right? So we can do that same thing if we'd like. We can do first times first, last times last, outsides, insides, all that same stuff. So if we want to do that, so we'd take b times the b, which b times b is b squared. That was first. Outside is b times 5, so 5b. Inside would be 5 times b, which is also 5b. And then our last would be 5 times 5, which is 25. With these, our middle two here should always be the same. So if you do outside and inside, those should always be the same value because we're taking the same two letters or numbers and multiplying them. So we were taking 5 times, or the b times 5 and 5 times b, same situation, so we should get the same number there. So then again, like we were doing with FOIL, usually we can combine our middles. So this would be b squared plus those would combine to be 10b plus 25. And that would be our answer. So looking back up here to what it said for square of a sum, that was basically our first value squared. So here if we look, our first value was b, so we took that and squared it for this, which b squared, so that checks out. Our middle is 2 times whatever our a value is times our b value. So if we took our a value and our b value, so here b and the 5, if we multiply those, that would be 5b, and then we take and double that, well that would be 10b, that's what we got there. And then for the last letter here, b squared, you're taking whatever's listed last, so 5, and taking that times itself. So 5 times 5, 25. Okay, so the square of a sum is basically just a shortcut, so you don't have to do the whole foiling out. You can feel free to do the whole foiling out because usually that's what I do because I can never remember these. But like I said, these will be more helpful in chapter 10 if you can kind of remember them now. Okay, so let's do the same thing on the next one. So we've got c minus 3 squared, so that would be c minus 3 times c minus 3 So I could change these to adding the opposite if I want, make them negative 3's. Then I can do FOIL, so I could do first times first, so c times c, which would be c squared. And then I could take outside, which would be c times negative 3, which would be negative 3c. Then inside, 3 times c would be negative 3c. And then last would be negative 3 times negative 3, which would be a positive 9. So then again here, these middles, when I'm doing these, they should always come out to be the same. So it would be c squared plus, and then when I combine my middles together, that would give me negative 6c plus 9. And if I look back up, this one would be an example of a square of a difference because it was subtracting in between those. It should follow that same pattern where my first letter here is the first thing times itself, so c times c. Well, we got c squared. The middle thing is negative or minus, so either way there. And then 2 times our a times our b. Well, here our a and our b would be c and negative 3. So if I take c times negative 3, that's negative 3c, times 2, that would be negative 6c. So that checks out. And then my last would be b squared, so the last thing times itself. So negative 3 times negative 3 comes out to be a positive 9. So like I said, if you want to do it the short way, totally fine. Like I'll kind of just show you the short way on this next one here. So if I wanted to expand it out, I could. 2d plus 1 times 2d plus 1. So if I'm going the quick way here, I'm going to take my first things and multiply those for my a squared. So that would be 4d squared. Then I'm going to take my first thing, so 2d, times my other thing that's in the parentheses, so like the b in this case up here, but 1 here, so 2d times 1 is 2d. Then I'm going to take and double that, which would be 4d, so plus 4d. And then it would be my b times itself, so in this case would be 1, which would end up being 1. Okay? Now if you're not comfortable skipping those steps to get that, don't worry about it, just do FOIL out. Usually I'm going to show you the FOIL way because I know a lot of people aren't comfortable skipping through the steps. But if you want to skip through the steps and just do the quick way, totally fine. Okay, so I'm going to do the long way on D here. I'm going to do 3e minus 3f times 3e minus 3f. So we could change those to adding the opposite. Do our FOIL here, so 3e times 3 would be 9e squared. Our outside would be 3e times negative 3f, which would be negative 9ef. Inside would be negative 3f times 3e, which would be negative 9fe or ef, either way. And then our last would be negative 3f times negative 3f, which would be 9f squared. Then again, we've talked about this before, even though these letters are different here, so you got EF and then FE, so even though they're switched around there, those still can be added together because multiplication you can change the order on, and that's fine. So we still can combine these together and get 18 EF or FE, either way, and then drop down our 9 E squared and drop down our 9F squared. Okay? Okay, so you guys can try out on page 406, A through D. So A, they got y squared plus 6y plus 9. B, they got 9g squared plus 6gh plus h squared. C, they got d squared minus 4d plus 4. And D, they got 16x squared minus 24xy plus 9y squared. Okay? Okay, so the next thing here, we have an example that is from the book on page 406. So I'm going to read that to you. So it says, in a certain population, a parent has a 10% chance of passing a gene for brown eyes to its offspring. If an offspring receives the eye color gene from its mother, and one from its mother and one from its father, what is the probability that the offspring will receive at least one gene for brown eyes? Okay, so we've got a couple things here. We've got the genes from the mom and the genes from the dad, and I don't know if they talk about, I don't think they talk about that. But basically how it works is you get the genes from your parents, and then they're either recessive or, I don't remember what the other one is, but one means you're going to get it and the other one means you're not. So here we've got a 10% chance of passing the gene for brown eyes, which also means we have a 90% chance of not passing it. Okay, so the capital B here stands for us passing the gene on to our kids because that's 10%, and the 0.9 is 90%, which would be the chance that we're not passing it to our kids. Because if you think about it, if there's a 10% chance you're going to give it to them, then there's a 90% chance you're not going to give it to them, because total those add to be 100%. So that's where they're getting the 0.1 and the 0.9 for 10% and 90%, because there's a 90% chance you're not getting it. So if you are getting it, that's capital B. If you're not getting it, that's lowercase b. Okay, so they've kind of got a picture there of what's going on, which is similar to when we did that garden example where we just kind of multiply the sides and do like an area type problem. So we're just going to do FOIL here just like we've been doing. Be careful that they have, since they have a capital B and a lowercase b, you have to keep them as capital and lowercase, otherwise you're going to get them screwed up here because they mean two different things. So we're going to take the 0.1 capital B times 0.1 capital B, which would be 0.01 capital B squared for our first. Our outside would be 0.1 capital B times 0.9 lowercase b, which would be 0.09, and then a capital B times a lowercase b. And those couldn't be b squared because the capital B and the lowercase b stand for different things. Then I do my insides, which would be the same exact values being multiplied, the 0.9 lowercase b, 0.8 uppercase b, so I'd get the same thing here, so 0.09 capital B, lowercase b, and then I would multiply my last, so it would be 0.9 times 0.9, which is 0.81, and then since I'm doing a lowercase b times a lowercase b, it would be lowercase b squared. Then I could take my middles, combine those guys, so 0.09 capital B lowercase b, or added to itself, would be 0.18 capital B lowercase b, and then I drop the rest of the stuff down. Now if I look back at the question here, they want to know, what's it say for the question? What is the probability that an offspring will receive at least one gene from brown eyes? So when I look at this here, the capital B means I'm getting the brown eyes one. So here, capital B squared would be I'm getting it from my mom and I'm getting it from my dad. These middle ones here, capital B and a lowercase b, is one parent gave me a brown-eyed gene, and then the other parent did not give me a brown-eyed gene. And then here, the last one with the lowercase b, both parents did not give me the brown-eyed trait. So if they want at least one parent gave it to you, well here, at least one parent's giving it to us because both parents do. Here, at least one parent gives us because one parent does give it to us. So if I add those two percentages together, 0.1 plus 0.18, total that gives me 0.19, which would be 19%. So there would be a 19% chance, if these were your numbers here, that your parent is going to give you the brown eyes gene. Now whether you have brown eyes or not, that kind of is up to whatever else is going on there, but that is your percentage. Alright, so we've got one more kind of special case scenario, which is called product of a sum and a difference. So again, we're using the same letters here, so like the A and the A are the same letter here, so if this was a 2, this would also be a 2, and then the B's are also the same. The only difference between what we're doing now and what we were doing before is we've got one that's addition and one that's subtraction, so that's the only difference. And you'll kind of see what happens here, because what ends up happening is we end up canceling out the middles and we only end up with 2 terms. So you'll kind of see this here when we multiply. So if I do my FOIL like I usually do, it would be 3 times the 3, which would be 9. 3 times the, think of that as a negative a. So negative 3a. Inside would be a times 3, which would be 3a. And then last would be a times a negative a, which would be negative a squared. Now what's going to happen on these is, since we multiplied one by the positive here and one by the negative, what ends up happening is these middles are going to be the same except for with a different sign. So when we go to add them, a negative 3a and a positive 3a, those end up canceling out. So we're just left with 9 and then plus a negative a squared, or that's the same as 9 minus a squared. So anytime you have product of a sum and a difference, and they're set up like this where it's the same letters and numbers being used, the middles are always going to cancel no matter what. So let's try another one here. So again, if we do our FOIL, so it would be first times first, so 5b times 5b would be 25b squared. Outside would be 5b times 2, which would be 10b. Inside, think of that as a negative 2, so negative 2 times 5b would be negative 10b. And then our last would be negative 2 times 2, which would be negative 4. So again here we've got a positive 10b and a negative 10b, so those middles end up canceling. So we'd have 25b squared minus 4. So again, you can use a shortcut way on these. So instead of doing this whole thing out, what you could do is you could just take the first thing times the first thing. So like in this one, 3 times 3, you get 9. And then you could take your last times your last, so a times a would be a squared. And then this one, you always just throw a subtraction in the middle. And that would be the same answer we got there. So again, they're just shortcut ways to do these. They'll be more helpful in Chapter 10, but it's important to kind of talk about them now so you have an idea what we're talking about in Chapter 10. But if you want to do it FOIL way, I'm totally fine with that, because I know that's probably what most of you are going to do anyway. So if we look at the 2 on page 407, E and F, E, they got x squared minus y squared, or it could be plus a negative y squared. And then F, they got 25 m squared minus 36 n squared. Okay, so that is all we've got for notes. So page 407, 10 to 32 even is your assignment.